Dan Perry here with another Dan on Tech video. In this video, we're going to revisit our trace route, which we visited a couple episodes ago. I had a question from a student who was still a little bit confused on a trace route and how it works. So I'm going to try to just go into a little bit more detail on trace route here. And so let's see if I bring up my whiteboard, and just forgive me, I'm not much of a drawer, but I'm going to try to draw this. We have a computer, and this computer, we need to find out how traffic from this computer, let's say computer A, gets to computer B. And it's going to go through several networks, maybe our own network, maybe the internet, several networks on the internet. So each time it goes from one network to another, it goes through a device called a router. A router is sort of a traffic cop. A router takes traffic coming in. It looks at the destination network and says, how do I have to get it from point A to point B? And then it sends it on. And I'm going to do a series of videos at some point in the future talking about routers and switches and how they actually work. Well, sometimes we want to know why or how that router is, or that traffic is getting from one point to another. Gamers like to know it so that they can try and find better routes, or look at their time. For network troubleshooting, we can use it to try to see why traffic is not being delivered to the destination. So the way traceroute works is you'll do the traceroute command, and you will put in the address of the destination computer B. What the traceroute command then does is use the ping. Remember, the ping utility does an ICMP ping echo request, so it sends out a message to the computer at the other end, and that computer at the other end then replies to it, and so you can find out if that machine is alive or not. Well, if we go back to the network layer of our TCP IP protocol, at the network layer there was a field called time to live, or TTL. Time to live. And different operating systems have different starting values. It might be 64 or 128 or 255. Every time that packet goes through a router, it takes that TTL value, subtracts 1 from it, and it creates a new header, a new network header with that new TTL value. So each time it subtracts 1. If it gets to a router and that router subtracts that 1 and now the value of TTL is 0, the router says, hey, I can't deliver that traffic, and it sends a message back to the computer saying, hey, I couldn't deliver that traffic. So it sends back a message. Well, when that computer gets that message back, it knows which router it came from. It knows it came from router A or B or C. So with our TTL and subtracting it, what we do with traceroute is traceroute when it first sends that first echo. It uses, again, that ping, that echo. When it sends out the first echo, it sends it out with a time to live equal to 1. So it comes with a time to live of 1. With that time to live of 1, what's going to happen is it hits this first router. I'm not sure, I've been trying to change the colors of my pens, but they don't seem to want to change. But it will hit the first router, and the first router decreases that time to live by 1. It becomes 0. It says, hey, I can't deliver it. Sends a message back to A. Well, when A gets it, the message came from this router, so it has the IP address of that router. If it's got the IP address of that router, then it knows where that router is. Well, so now it sends out another ping request, And this time it puts a time to live of 2. See if we can do it with highlight. So next time it's a time to live of 2. Well, so it gets through the first router, that decreases it by 1, so the time to live is 1. Gets to the second router, the time to live is now, it was 1. It decreases it by 1. So now the time to live is 0, with a 0 for your time to live. Well, it sends back a message to that router saying, I couldn't deliver that traffic. Well, now we know because that message came from that router. We have that router's address. We know where that router was. And then it will do that with the time to live of 3, 4, and continue up to whatever its max is. With Windows, the max will be a 30 when it quits. Or it gets a reply from the destination machine. So if it gets a reply from the destination machine, it knows it's at the end and quits. So every time it goes through a router, we're able now to identify that router. We know where that router is. So the trace route, that's how the trace route lets us know how the traffic is going, what routers it's going through. So it went through maybe this router, then this one to get to the end. So we know how many routers it went through. We know if it couldn't be delivered at the end. So traceroute is a way of, as it says, tracing the route a packet takes to get from point A to point B, and it is a very useful troubleshooting tool in networking when your traffic is not reaching its destination. I hope this explains it more. And I also had a question about the ARP utility, so I think the next one we're going to go in and revisit the ARP utility.